History often remembers successful aircraft. It rarely remembers the experimental machines that made those successes possible. These X-planes served as the hidden laboratories where the future of aviation was first proven. The Northrop X-21A was developed to investigate laminar flow control on swept wings using an active suction system designed to reduce aerodynamic drag. First flown in 1963, two modified WB-66D aircraft carried hundreds of thousands of tiny suction slots across their wings. Although the concept successfully gathered valuable aerodynamic data, contamination from dirt, rain, insects, and ice made the system too maintenance-intensive for operational use. The Bell X-22 explored vertical and short takeoff technology through four swiveling ducted fans powered by individual turboshaft engines. Two prototypes were built, with the surviving aircraft demonstrating stable hovering above 8,000 feet and conventional forward flight. Testing continued into the late 1980s, providing important research data for future VTOL aircraft development despite never entering production. The Marietta X-23A Prime was an uncrewed lifting body research vehicle created to study maneuverable atmospheric re-entry at hypersonic speeds. 3 missions were launched aboard Atlas rockets during 1966 and 1967. While the first 2 vehicles were lost during recovery, the third completed its mission successfully, validating cross-range re-entry concepts later incorporated into future lifting body programs. The Marietta X-24 began as the teardrop-shaped X-24A before being rebuilt into the sharply redesigned X-24B with improved aerodynamic efficiency. Released from a modified B-52, the aircraft demonstrated that a wingless lifting body could glide safely to a conventional runway. Its flight program directly influenced landing techniques later adopted for the space shuttle. The Bensen X-25 program evaluated lightweight autogyros as emergency escape vehicles for downed U.S. Air Force pilots during the Vietnam era. The powered X-25A offered limited independent flight, while the unpowered X-25B functioned as a gyroglider after parachute deployment. Although several aircraft were required for evaluation, operational testing never progressed before the program was cancelled. The X-26 program combined an unpowered sailplane with an exceptionally quiet powered reconnaissance aircraft. The X-26A trained U.S. Navy test pilots to recognize unusual flight characteristics, while the Lockheed-modified X-26B evolved into the Quiet Star concept for low-noise surveillance missions over Vietnam. Its slow-turning propeller and specialized engine installation significantly reduced acoustic detection during reconnaissance operations. The Lockheed X-27 designation was assigned to a proposed research aircraft derived from the CL-1200 Lancer, itself an advanced development of the F-104 Starfighter. Planned to evaluate high-performance engine technology, the project never advanced beyond the mock-up stage. Although several fuselage structures were reportedly started, no flying prototype was completed before the program was cancelled. The Pereira X-28A Osprey was a lightweight single-engine amphibious aircraft evaluated by the U.S. Navy for patrol operations across South Vietnam's rivers and canals. First flown in 1970, only one prototype entered military testing. Although the aircraft demonstrated practical low-cost operating capability, the conclusion of the Vietnam War ended further development before production could begin. The Grumman X became one of the most recognizable experimental aircraft ever built through its dramatic forward-swept wings, close-coupled canards, and extensive composite construction. 2 aircraft completed 437 research flights between 1984 and 1992, demonstrating stable supersonic flight and controlled maneuvering at angles of attack reaching 67 degrees, expanding knowledge of highly agile fighter aircraft design. The Rockwell X-30 represented the ambitious national aerospace plane program, which sought to create a single-stage-to-orbit vehicle powered by air-breathing scramjet engines. Although promoted as a future aircraft capable of dramatically reducing intercontinental travel times, overwhelming technical challenges and escalating costs prevented construction of a flyable prototype before the program ended in 1993. The Rockwell-MBB X-31 was developed to demonstrate post-stall maneuverability using thrust vectoring technology combined with advanced digital flight controls. First flown in 1990, 2 aircraft completed hundreds of research flights, successfully maintaining controlled flight at extremely high angles of attack. The program validated technologies that later influenced advanced fighter maneuvering and modern flight control system development. The Boeing X-32 was Boeing's entry in the Joint Strike Fighter competition, designed to satisfy conventional, carrier, and short takeoff requirements with a common airframe. Two prototypes were built and extensively tested beginning in 2000. Although the aircraft met many performance goals, its short takeoff and vertical landing system proved less effective than its competitor, ending the program after the competition. The Lockheed Martin X-33 was designed as a reusable single-stage-to-orbit technology demonstrator, supporting the planned VentureStar launch vehicle. Featuring a lifting body configuration and linear aerospike engines, the project reached an advanced stage of construction before cancellation. Development ended in 2001 after repeated failures of its composite liquid hydrogen fuel tank and continuing budget challenges prevented flight testing. The Orbital Sciences X-34 was intended as a reusable uncrewed rocket-powered research aircraft capable of reaching hypersonic speeds during suborbital missions. Two completed airframes underwent towing and captive carry testing beneath an L-1011 carrier aircraft. Despite extensive preparation, no powered flights occurred before NASA canceled the program in 2001, following funding changes and shifting research priorities. The Lockheed Martin X-35 competed in the Joint Strike Fighter program with conventional, short takeoff, and carrier-based configurations built around a common design. Its innovative shaft-driven lift fans successfully demonstrated vertical landing without sacrificing supersonic performance. Following successful flight testing, the X-35 was selected as the winning design and ultimately evolved into today's F-35 Lightning II. The McDonnell Douglas X-36 was a remotely piloted research aircraft built to evaluate tailless fighter concepts using canards, split control surfaces, and thrust vectoring instead of conventional tails. Flying at 28% scale, two aircraft completed more than 30 successful research flights. The program demonstrated that advanced flight control computers could safely stabilize highly unconventional aircraft configurations. The Boeing X-37 began as a NASA technology demonstrator before transitioning into a classified U.S. military orbital spaceplane program. The reusable X-37B completed multiple long-duration missions, remaining in orbit for hundreds of days while conducting autonomous experiments. Its reusable design, automated landing capability, and extended endurance continue advancing spaceflight technologies under the United States Space Force. The NASA X-38 was developed as an emergency crew return vehicle for astronauts aboard the International Space Station. Based on lifting body research from the earlier X-24 program, it used a massive steerable parafoil for precision landings. Several atmospheric test vehicles successfully completed drop tests before the project was cancelled in 2002 because of budget reductions. Unlike every other designation in this sequence, the X-39 was never assigned to an operational research aircraft. The number remained reserved for potential Air Force experimental programs involving advanced unmanned technologies and low observable concepts. Although frequently linked to classified aviation rumors, no verified aircraft officially carried the X-39 designation or completed any flight testing. The Boeing X-40A served as a compact technology demonstrator for autonomous approach and landing systems, later incorporated into the X-37 program. Released from helicopters during a series of glide tests, the unpowered vehicle accurately navigated and landed without pilot input. Its successful demonstrations significantly reduced development risk before orbital testing of the larger X-37 began.